Okay. So this is the data, right? And what we said was we will have subject highest here, right? Okay. And subject highest. Now, when you say J, 0 will be one subject, 2 will be. Now, we're talking about students here. So when you talk about students, we refer to I. Okay. And since J is the inner loop and we're talking from J here, we're looking at the subjects. So J represents the subject, correct? So I'm going to check if, okay, if this marks, right? So this is your marks for first subject, right? When J is 0. So if marks is greater than, okay, so here we are not looking for equal to, okay, we will, because we only need the number, right? So that's why here we needed both name and number, right? And if the two students with same marks, we want to store both information, but here not important, right? If we get our highest value, this is good enough. So I'm saying if marks, okay, greater than, okay, subject highest of J, okay, then subject highest of J equal to marks this. Okay, and I think it should be it. Let's go and see if I got it right or not. I'm going to say print. Um, uh, what is the spelling of highest? Highest marks for subjects. Now here we'll print the subjects variable, subjects is subjects. Let's see if it is correct. Yeah, I think this is correct, right? For maths, it is 88. For science, it is 87. And for English, it is 78. That's it. Okay. So here, see, we are checking each marks here. So this mark, if this is greater than what we already have in the data, which is -1. So initially, all the -1 will be replaced with the three values. And you move to the next list. That is it. They got highest mark for is. I move this. I don't know why my internet says my connectivity is bad today. So please let me know if you don't hear something.
Yes, sometimes it was bit breaking.
Breaking line. Yeah. Let's see.
Yeah,
Okay.
now, yeah.
Better. Okay. Any questions, guys? All good? Okay. So let's look at a few things. Okay. A few. I'm going to copy this. Few other properties of dictionary, which we have not covered while doing this program. So, just like list here, you also have copy, deep copy and shallow copy. Okay, so this is marks, right? And I say marks 2 equal to marks. and I say marks 3, okay, equal to marks dot copy, correct? And now I add something to marks dot update, and I add another dictionary to it. So I will add, let's say, Mahi colon 71, 91, 81, let's say. Now when I print, I'm printing marks, okay? Marks. And next I'll print 2 and 3 as well. So what do you expect in 2 and 3? What do you expect? We have done this in the list. What do you expect here? So see, here we created marks 2 and 3, okay, which is equal to marks, correct? So that means marks 2 and 3, okay, will have same data, okay, till here. Okay, so if I say print before update, okay, and if I copy and paste the stuff here, okay, and I'll say here after update, but let me comment it, okay? Let me comment this part, okay? I don't want to run this part for now. So when you run it here, okay, all these three are same, right? So equal to and dot copy, okay, both will create a duplicate values here. So see, marks 2 and 3, okay, have exactly same values as marks, right? Probably this is what we expect. But what is the difference between these two? What is between just equal to and equal to dot copy? Okay, the difference we'll see here. So I have made modification to marks, the original dictionary. Okay, I have made modifications to the original dictionary. Now what happens, you see? So marks we added Mahi, so it should have Mahi grade. But even see, marks 2 also got automatically added to Mahi, right? So this is called deep copy. Deep copy means, okay, they are pointing to the same values, okay? And when you say dot copy creates a copy and then that's it, okay? So marks 3 will create a copy of marks here, and then marks 3 and marks, they are different. Okay, there is no linkage after that. It's like taking a photocopy. After photocopy, okay, those two documents become separate documents. But equal to is like saying that, okay, they both are same document. Okay, so that's why if I make any changes to marks 2, I delete, okay, I can pop. Okay, so we haven't done pop, right? So we have pop. Now I can say marks 2, is it 2 or 3? Oh, yeah, 2, right? So I'll say marks 2 dot pop. So you have two pop thing. One is pop with key, another is pop item. Okay. So by default, okay, pop item, okay, will remove any value. Okay. Definition says any value, but the way it is designed is it removes the last added value to the list. So if I say pop item, Mahi will get deleted. Okay, or you can decide which key to remove. That's why I'm going to use pop. So pop item, you need to give the value that you want to remove. Okay, I mean, sorry. Pop item doesn't need anything to remove. Okay, but it removes the last item that you added. Okay, so if I use pop item here, Mahi will get removed because that's the last value that we added. Pop, just pop is where you give the key. Let's say I want to remove Kapil. So I'll put now when you see, okay, Mahi got added to marks 2, even though we added Mahi to marks, correct? And we removed Kapil from marks 2, but even marks got it removed. Okay, that means they are same. They are, okay, they are not different dictionary. They are same dictionary. So equal to will create a duplicate name, but the main underlying values will remain same. Dot copy creates a duplicate copy. So the moment you create a copy, they are same, right? But after that, they need not be same. You can write anything on photocopy paper, right? So they are not same after photocopy. After copy, they behave like a two different dictionaries. Okay, so this is how you remove members, this is how you add members to dictionary, and this is how you create a duplicate copy. Okay, so yeah, these are the different methods we use as part of dictionary. Okay, now we'll move on to another collection, okay, which is called as sets. Okay, so what is set? Okay, see, if I ask you, name 5 fruits. Okay. I ask you, okay, give me names of 5 fruits. So if you tell me apple, 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 apple 5 times, does that make it 5 fruit?
No.
No, right? Okay. But when you talk about dictionary, list, or tuple, it means that, I can create L1 equal to apple, 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 right? So now if I say how many values are in L1, how many, or I'll say values in, I'll directly type the answer, right? L1 equal to, how do I find the values in L1? Len of L1, right? So now when you run it, you get 5. It says, oh, you got 5 values. But we know that that's not right, okay? You cannot. So this is where we use set. Okay, and how do you declare set? Okay, you must have done this in the maths classes in high school. Set theory, right? How do you declare set? Set is also declared using a curly braces. What else is declared using curly bracket?
Dictionary.
Dictionary, yes. So we just did dictionary. So dictionaries are also declared using curly bracket. So now if I say the type, okay, since you have not added the value here, so Python will not know what you are trying to do. So if I say what is the type of S1, it will tell you dictionary. Okay, because by default curly bracket is used for dictionary. Now, okay, what I'll do, I will add apple, apple, apple. Okay, and now if I type same thing, what did you get? Set. Because when you don't put colon and you put comma here without colon, because if you put colon, then it knows, okay, you're using key colon value. So it has to be a dictionary. But when you don't put colon, if you put values like this, okay, it knows that you are trying to use it like a set. See, now it's given type as set. So set is again linear mutable collection. Only difference here is unordered. Sets are unordered, unlike your list and tuple. List and tuple both are ordered. So what is difference between list and set? Difference between list and set. List is ordered, sets are unordered. What is similarity between list and set? Both are mutable. What is similarity between tuple and set? Both are linear, right? That's it. Dissimilarity, they are, one is ordered, other is unordered. One is mutable, other is immutable. Tuples are immutable, sets are mutable. Set is unordered, tuple is ordered. Okay. Now you see here, now if I say value print values in, I'll say S1, right? And change it to S1. See, it caught your mistake. Even though we entered so many apples, it says the value in S1 is 1. Okay, this is the first property of set. It removes duplicate values. If I say name 5 cities and you say New York, New York, New York, New York 5 times, doesn't make it 5 cities, it's still 1. That's what, okay, um, S1 or set does. It removes duplicate. Okay, this is your property 1. Removes duplicate values. Okay, now second thing. Now let's say, okay, I ask you to name 5 fruits. So you named it like apple, say banana, orange, grapes, and let's say mango. Okay, so I asked you to name 5 fruits. You named 5 fruits here. Now I ask you to name, let's say this is, I ask somebody else. Now I ask you again, name, okay, 5 more fruits apart from these 5. So you'll say, okay, you will say apple, banana, orange. I'll put it after mango. Are they different? Should you consider them different?
Some are duplicated.
They are not different. They are same.
Oh, ordered differently. Yeah.
Order is different, but they are same. If I tell you name 5 other than these 5, you say, okay, I'll reverse the order. I'll put it different order. No. Okay, they are still the same. Order doesn't match. Or what you call order doesn't matter. In list and tuple order matter. That's why we call them ordered collection. This is non-order. Order does not match. So set is only to represent a value. The set theory that we do in mathematics, okay, is only to represent the value. Set is used to represent. Okay, set is used to represent. There is no meaning in the order. Of course, I cannot represent same thing twice. Right? So property 1, okay, duplicate value is not allowed. Property 2, okay, order doesn't matter. Okay, these are the 2 properties of set theory. So the concept, why do we need set? Where is the set used? Set is used to represent values. Right? Set is used to represent the values. Okay. So like for example, if I go to Paint, just give me a second. I'm on Paint, okay, and let's say this is your set of values here. I say, okay, mark 5 fruits here. Now you'll say this is apple, this is banana, this is orange, this is grapes, this is mango. Now, whether I put apple here or banana here, does it have any difference? No, it should not have any difference. It doesn't matter where you put these values. It is just to represent. Right? So that's what. So whether you put apple on first position or apple on third position or fifth position doesn't really matter. Apple, banana, orange, grapes, right? It doesn't matter, okay? It doesn't matter where you put. So sets are only to represent the value. The practical use of set is to represent values. That's it. And of course, logically also, you can represent one value only once, right? You cannot say that, I have apple, I have apple, I have apple enough is to tell me that you have apple. You don't have to repeat it 10 times. Okay. So this is the purpose of set. Okay. Then what are different properties of set? Okay. So let's say, okay, this is your set one. And let's say like this is, let's say person one has these fruit and person two, okay, let's say we have grapes and mango, and then we'll add something different. Right? And let's add one more. Okay. So in total, how many fruits I have? Let's say, uh, you bought these 5 fruits and I bought these 5 fruits. So how many fruits we have in total?
8.
8. That is what your union property does. Okay, union. So now if I perform union, how do you perform union? So there are 2 ways to do union. Okay, one is using method and other is using what you call symbol. Okay, so let's see. So I will say print. Okay, you have S1 pipe sign. You see the straight line, vertical line, which is just above your enter key, right? So that's called pipe sign. So you put pipe sign. Okay, so I say S1 pipe S2, or I say print S1 dot, okay, union S2. Okay, and now you run it. Count how many values are there. 3 plus 3, 6 plus 2. So Shiva is right? So when you add them together, you don't get 10, you get only 8. Correct? So that's union. Okay. Total, how many values? Since there are 2 common values, you'll count them only once. You don't count them multiple times. And what we do generally, okay, we also talk about, okay, set diagram. Okay, so again, if you remember your classes, we used to draw set diagrams. How do you draw set diagrams? Let's go back to this. Okay, so let's say you have, this is your set 1 and this is your set 2. So if I do union, okay, if I perform union, okay, so you will take this value, right? So see, this is, okay, so there is overlap. This is common part, correct? So this value in our case are 3 fruits. And this value is again 3 fruits. And then common is again 2 fruits. 3 plus 3 plus 2. So you get 8. This is called union. Union means how many you are adding 2 sets. You're adding 2 sets. Okay. And when you add them, of course, you have to remove duplicate because in set, duplicate values are not allowed. Right? So you are removing duplicate. Right? So that's the purpose of union. Okay. In set, union is to add 2 set together. Okay. Next we have is called intersection. So let's say I bought those 5 fruits and you bought the next 5 fruits. How many fruits did we buy in common? How many fruits did we buy in common?
There are, the set is,
This one, right? 2 fruits we bought in common. Again, if you go back. Okay. Grapes and mango. Grapes and mango are common. Right? So we got 2 fruits together. And that's what we call it as intersection. The property is called intersection. Intersection. Intersection is finding the common elements between them. Okay. Next one is minus. Okay. So, okay, I'm saying I've got this. Okay, this is my fruit. Now, I will say, from my fruit, you take away your fruit. From my fruit, you take away, that's what minus means, right? From 5, you take away 3. 5 minus 3. I'm saying from my set of fruits, you take away your set of fruits. So what can you take away? So this is your set of fruits. Can you take away grapes from my set of fruit?
Yeah, it's common.
Can you take away grapes? So this is your set of fruit. So this is my set of fruit. Can you take away grapes from me? Yes, you can take
Yeah,
away
it's
grapes from
common.
me.
And
Can you take
mango.
away mango from me? Yes, you can take away mango from me. Can you take away guava from me?
No.
No, I don't have guava, right?
No, sir.
Yeah. So you are, asking me to give $100 and I don't have $100. Can you take away $100 from me? No, you can't. Guava, you can't. Pineapple, you can't. Cherry, you can't. What am I left with?
3.
Apple, banana, orange. Okay, these are the fruits, and you take away these fruits. So you take away grapes and mango, but you can't take away these 3. So what I'm left with now is just apple, banana, orange. This is called minus. Okay, S1 minus S2. Okay, let's do this. Okay, we'll print this here so that we know what we are doing. So this is union we discussed. Then we spoke about intersection, right? Intersection is about common values between the sets, right? So again, there are 2 ways to do it. One way is you use what we call as the ampersand sign. And sign, ampersand and. Okay, so use and, or you can say intersection. Okay, so when you run it, you get common, right? Both are giving same answer. Mango, grapes, these are the common fruits between these two. Then we spoke about difference. Difference or minus, right? Difference, that is your minus. So what did we say? Okay, you remove set of values from a set, right? From another set. So same thing, okay? So here also we have symbol and method. You can say S1 minus S2 or S1 difference S2. Okay? So what did we say? S1 minus S2 should give us apple, banana, orange. Okay? Apple, banana, orange. Okay? Now, if I do S2 minus S1, then what happens? S2 minus S1. S2 difference S1. What happens? So now I am taking away fruit from you. These are the fruits you have. I am saying, okay, give me apple. Do you have apple? No. So you can't give me apple. Give me banana. Give me orange. You can't. Now I say, give me grapes. You'll give me grapes. Mango, give me mango. You'll give me mango. So what are you left with?
Guava, pineapple, cherry.
Right? So this is what you are left with. Guava, pineapple, and cherry. So that's what S1 minus S2 it does, or S2 minus S1. S1 minus S2 is not same as S2 minus S1. Can you tell me in which case S1 minus S2 will be same as S2 minus S1? Think and tell me, okay, in which case S2 minus S1 will be same as S1 minus S2?
They both have the same
Both
contents.
have same values, yes. Okay, so like if you do S1 minus S1, if you do, then nothing is left blank, and S1 minus S2. So if both S1 and S2 have same set of values, then okay, S1 minus S2 will be same, and that will be nothing, blank. So whatever you have, everything is taken away. Correct? Only that's when S1 and S1 and S2 will be same. So that's different. So if I have to represent this in the in the set plot, okay. So here this is your, let's say, S1, and this is S2. So I'm taking away from S1, I'm taking away S2. Okay, so this is what is left. Okay, this is what is left. So this is your difference. Then you have symmetric difference. Okay, symmetric difference means it is S1 minus S2 and S2 minus S1, both is happening. So from S1 you take away S2, and from S2 you take away S1. Then what is left? So this is S1. From this you take away S2, and this is your S2, you take away S1. So from S1, if you take away S2, this is what you get. And from S2, if you take away S1, this is what you get. Okay, so output is entire value except the common part. From S1, you're taking away S2. From S2, you're taking away S1. So the answer is entire thing except the common part. Okay, this is what we say symmetric difference. Symmetric difference. Okay. So these are the operations that we generally perform on sets. Okay. Then you have few concepts. Okay. When you have set 1 like this and set 2 like this, so we call them, there's no common element between them. Okay. So let's say, this one has 1, 2, 3, 4, 5, and this has 6, 7, 8, 9, 10. Set 1 has values 1, 2, 3, 4, 5, and set 2 has 6, 7, 8, 9, 10. So there's no common element between them. We call them as disjoint sets. Okay, these are disjoint sets, right? There is no common element between them. All of these are joints. Okay, all of these are joint sets. Why joint? Because they all have some common element between them. Right? Sorry, here it is disjoint, okay? Spelling is wrong, so let me correct it. Disjoint, okay? We call them as disjoint sets, okay? Because there is no joint, there is no common element with this is the common part, overlapping part. That's why we call them as joint set. These are all disjoint set. Then you also come across like superset and subset. So let's say if I have a set here and another set here, right? So let me call this, okay? I'll call this as S2 or S1, and this is your S2. Now, in this case, S2 is superset of S1. Okay, what is meaning of superset? Superset means S2 has all the values of S1. So if S1 is, let's say, 1, 2, 3, right? And S2, okay, has 1, 2, 3. Okay, that's why S1 is inside S2. And it might have more values. Then we say S2 is superset and S1 is subset. S2 is superset and S1 is subset. So you have superset and subset. Subset means sub, the part of it. Super is the bigger one, right? So if all the values of S1 is in S2, then S2 is superset. If S1 has some, lower values, okay, then it's called a subset. So these are the concepts that you will come across, okay. Now we will see, like we have done till difference. Let's see others. And with that, we will end our sets discussion, okay. So let's go back. Okay, so this is your union, this is your difference, symmetric difference, right? Symmetric difference. Now for symmetric difference, okay, what I'll do. So again, here also you have two ways to do it. One, okay, the symbol, okay. So the symbol here is the up arrow key. Where is that? 6. You see on the 6, you have the sign. That is the symmetric difference signs. And here you can say symmetric difference. Okay, so symmetric difference will give us the common part. Okay, I mean entire set except the common part. So what is common here? Your mango and grapes. So see, you have everything, all the 8 except the 2. That means 6 values you will get. That's your symmetric difference. And then you can check, is S1 joint or not? So I can check, like print S1 dot is. You see, is disjoint, subset, superset. Is S1 disjoint S2? What do you answer? Are they disjoint?
No.
No, they are not disjoint because they have common elements. So what will we get answer? We'll get answer as false. So we get false. That means they are not disjoint. Okay. So you get false. So if I create here S1 equal to 1, 2, 3 and S2, okay, I'm reassigning the values through S1 and S2, okay. 4, 5, 6. Now in this case, it will be true. Okay, there is no common element between them. So this is true. They are disjoint. Is S1 superset? Print S1 dot is superset S2. No, okay. Obviously, okay, when they are disjoint, it can't be superset or subset. Superset means all the values of S2 has to be in S1. So S2 has 4, 5, 6. Now, if I add 4, 5, 6 to here, then yes, S1 becomes superset true. And S2 is subset. Okay. So these are the properties of set. Okay. We don't use directly these properties while working, but you might end up in a situation where you have to perform set operation. You have data in list and you have to perform set operation. Let's say simple example. Okay. Okay. I asked you, give me values here, 5 values. So you gave me apple, apple, apple. Now I want to remove the duplicate values from this list. I want to remove duplicate values from this list. What should I do? Says, okay, you want to remove duplicate, you say L1 equal to set of L1. I'm converting list to set. So remember, okay, sets, the lists, and your tuples. Okay, they are convertible in each other's form. Okay. Set can be converted to list. Set can be converted to tuple. List can be converted to set. List can be converted to tuple. Tuple can be converted to list. Tuple can be converted to set. I want to remove duplicate values from L1. Okay, great. You say L1 equal to set of L1. Now, but L1 becomes now set. So I will convert this into list again. I'm converting back to list. So now your L1 is list. How do you know L1 is list? If you say L1 dot, you see these are properties of list, not properties of set. So I converted into set and again I converted back into list. So now if I print L1, okay, you see, you get only one value. See, it's a list. That's why I use a square bracket. Okay, and it has just one value because it has removed. When you convert into set, set will remove the duplicate values, right? That's the property of set. So you might have data in list, but you might have to perform those operation of set. So convert into set, perform those operation and reconvert back into list. Why can't we use set directly? The problem is sets are unordered. Sets are unordered, so you cannot access each member of the set. You have to access set as the entire member. Okay. What I'm trying to say is, if you take S1 itself here. Okay, so let's say I put S1 here and now I print S1. Let's run it and see what happens. Okay, I gave 1, 2, 3, 4, 5, 6. It gave us 1, 2, 3, 4, 5, 6. Okay. Okay, so it's giving value in the same form, but we can't trust this. Okay, it may not give values in the same format. It can give in different format. Let me put 4 here and see if there is any change. Yeah, you see this? I said 432, but the output it gave us is 234. It has rearranged. So that's why we cannot trust the order of sets. We cannot trust the order. I give 423, but it has rearranged to 234. Okay, we cannot trust the order. That's why we call it as unordered. Okay, so sets are unordered. You cannot trust the set. If you want to trust the order of sets, then you have to convert into list. Okay, so that's why sets in set form it is not useful, but the properties are very useful. Okay, so with that we conclude our collections discussion, and tomorrow when we meet, we will start a new topic called functions. So far we've been using all inbuilt functions. Your print is inbuilt function, your input is inbuilt function. Okay, now we will be writing our own functions. We will be writing our own functions. Okay, any questions?